Today in this lecture we will solve some network theory question based on transient analysis. So this is the question: in the following circuit, switch S is closed at t is equal to 0. This is the switch. The rate of change of current di upon dt 0 plus is given by. We have to find the rate of change of current at 0 plus. We have already discussed for this 0 plus, draw the circuit at t is equal to 0 plus, and then you can find the di upon dt at 0 t is equal to 0 plus. So first draw the circuit at 0 plus, and whatever has been asked for t is equal to 0 plus you can find, whether it is v0 plus, i0 plus in any branch you can find. So whenever you see that 0 plus, just draw the circuit at t is equal to 0 plus, then you can find whatever has been asked for t is equal to 0 plus, whether it is current, whether it is voltage across any branch, you can find. So this we are trying the circuit at t is equal to 0 plus. For t is equal to 0 plus, this current will depends, the inductor current depends upon 0 minus current. Inductor current is IL 0 minus plus is IL 0 plus, 0 minus. However, the switch is open. At 0 minus, the switch is open, so there was no current. So inductor current at 0 plus is equal to 0. Inductor current at 0 plus is 0. So you can draw it. You can draw it like this. This is the constant current source. Just draw the circuit at t is equal to 0 plus, and then you can find whatever asked for t is equal to 0 plus. Here they have asked the rate of change. So at 0 plus the switch is closed. This is R, and this inductor. There is no current. Either you can show it as an open circuit. Open circuit दिखा सकते हैं, or as we have discussed, show inductor as a constant current source. The current at 0 plus is the current equal to 0 minus. So is a constant current source. IL 0 plus is 0. It is similar to saying that it is open. No current is open. Just we are writing as we have discussed. Represent the inductor as a constant current source. The current is equal to 0 minus. Similarly, we have represented. In a way, we are saying, एक तरीके से हम कर रहे हैं, this is open circuit. No current means open circuit. Both are same. ठीक है? Now this. Now what di upon dt is given by. Now this is. So the one way is to we can say, right, we know that voltage across inductor is L di upon dt. This is the expression of the voltage at inductor. You can use this. You can use this to find out this di upon dt. So di upon dt is just VL upon L is equal to di upon. Now they have asked for t is equal to 0 plus. This figure you can find from this figure. Just use this. So VL at 0 plus, VL voltage across inductor at 0 plus is equal to L di current across inductor at 0 plus upon dt. So VL by L is equal to di 0 plus upon. So just you have to find VL at 0 plus, VL at 0 plus, VL at voltage across inductor at 0 plus is voltage across inductor. This is 0 means 0 current, or you can say open. जो open है या 0 current बात बराबर है. There is no current flowing through this. So this voltage will be the voltage across this. This voltage will be voltage across this. So the VL is IS into RS. VL at t is equal to 0 plus is IS into RS is equal to di 0 plus upon d. Thus you have obtained the answer. This is the correct. One other way you can also find it by another approach also. in which you write the expression of the current. We have obtained the solution, but there can be another approach. एक दूसरा अप्रोच भी हो सकता है. कोई बच्चा चाहे तो इसे ऐसे ना करके सीधे सीधे क्या करे, वो क्या करे कि करंट का एक्सप्रेशन लिख दे. वो क्या करे, करंट का एक्सप्रेशन लिख दे. मैं इसे मिटा रहा हूं, आप लिख लिए होंगे. आई एम जस्ट इरेजिंग इट. One method is this. The question has been solved. The other method could be that write the expression of the current ILT after the switch is closed. After the switch is closed, current is initially zero. It is a rising current. It is a rising, or you can write like this. The generalized expression is I infinity plus I 0 plus minus I infinity e to the power minus t upon. That is I infinity is Is by Rs plus current division rule into. This is I infinity. Switch is closed. Inductor behave as a short circuit at infinity at a steady state. Incoming current upon total impedance upon opposite branch resistance, the current through this. This we have. Plus I0 is 0 minus I infinity is same. Is Rs plus R e to the power minus t. This is the expression of the current. You can write it Is Rs upon Rs plus R 1 minus e to the power minus 1. Expression of rising current. Expression of at t is equal to 0, the current is 0, at t is equal to infinity, this is the current. This is the current. Okay. So now just differentiate it. So we have to find di upon dt at t is equal to 0. Differentiate it and put t is equal to 0. When you differentiate, it will be Is Rs plus R, differentiation upon 0. Now this constant will be out, 1 by tau, and putting t is equal to 0, this will become 1. This will become 1. So this is the differentiation. Tau is equal to, see the circuit, tau is equal to L by Rs plus R. Just put it there. You will get Is Rs by Rs plus R. Tau is equal to L by Rs plus R. This is at di upon dt. Write it there. I have already at t is equal to di upon dt. Just I am erasing it. This is di upon dt at t is equal to 0 plus. I have differentiated and then I have put t is equal to 0. This factor was there. In this differentiation, this factor is there. Now put t is equal to 0. In this differentiation, this factor is there, t is there. After putting t is equal to 0, this is the expression. So we have got the same answer. This is also the other way. Either you draw the circuit at t is equal to 0 plus. Finding the current across inductor is easy because voltage across inductor is related to the change of current. Finding that we have to find the change of current, the rate of change of current. The rate of change of current, we have to find the rate of change of current. Find how to find it, because the voltage depends upon the rate of change of current. So finding rate of change of current is easy. You can easily find out. Other way, write the expression of the current. This is the expression of the current, of rising current, and you can differentiate it to find out the rate of change of current. Then put it t is equal to 0, you will get the answer. So these are the two ways through which you can solve the question. This is a very interesting question asked in GATE 2009. The time domain behavior of an RL circuit is represented by this equation, and then they have given for an initial current I0 is equal to V0 by R. A steady state value of the current is given by These are the four options. What is the steady state value of the current? So in this question, first I would like to draw your kind attention on this factor. Very wisely, they have introduced this factor. Earlier, this is the RL circuit which we have studied, excited by a constant DC source. Earlier we have studied this. Now instead of constant DC source, they have given this expression. Instead of the constant DC source, they have used this excitation. Here, just concentrate on this. We have V minus L di upon dt minus IR is equal to 0. L. This. And then L di upon dt plus IR is equal to this. But instead of V, constant V, this is the expression. Just concentrate here. For this we have already seen the solution. It comes out to be I infinity plus I0 plus minus I infinity e to the power minus t upon tau. For this condition, when it is excited by a DC source, we have already derived constant DC source. This is the factor. Multiple time I have written. This is the expression. I as a function of time. But here, when you notice here, very interestingly, this factor at a steady state, this factor is decaying to 0. This entire factor, actually, this is the excitation. Time, the excitation is like this. It reaches to 0. This. So in a steady state, it is similar to excited by a DC source. It is similar to excited by a DC source. And in a steady state, they have R. So, in a steady state, the current through, in this circuit, the current is, the inductor behaves as a short, the current becomes V by R. Applied voltage by R. The current becomes, in this circuit, V by R. Similar is the situation at a steady state. This is 0. This is 0, and now at a steady state only a constant DC is present. But this excitation, this component decays to 0. So similar is the situation. So in a steady state there is no change, no variation. It is excited by a constant DC source at a steady state. So the current, the inductor will behave as a short, the inductor will behave as a short, and the current will be like this circuit. It will be V by R. So the correct option is, if this is V0, this V0 is V0, so it is V0 by R. So in this way you have solved this question. One other approach which I thought that this can be solved in other fashion also, that you take Laplace transform. I have already discussed that solving a integral differential equation becomes easy once we go through the Laplace transform method. So this I have just shown here. What I have done, we have already got the solution. What I have done, that this is the mathematical question now. What is the value of the current at IT, value of the current IT at t at can be chosen. Now look in mathematical manner. Look mathematically. Observe mathematically. I not a 0. Taking Laplace transform on the both sides. Laplace transform of this differentiation is IS current in Laplace domain minus, if Laplace transform of the differentiation is SIS minus I. This is the Laplace transform. The initial current is there, so I have this factor is present. R into current into IS Laplace domain V0, Laplace transform of constant 1 by S, Laplace transform sin t is 1 by S square plus 1, A square plus B square. This factor is there. How it changes? 1 by S plus A whole square, if e to the power minus at, if it is e to the power for this, I am writing here, e to the power minus at sin t. Laplace transform of this is 1 by s plus a whole square plus this. So this factor is there. I have written it separately. So this factor is there. S plus, instead of a it is r by l, in place of a it is r by l square. Okay, lis, just I have moved this to in that side, li0 in that side. Now just write the value of initial current v naught by r already given, so it becomes, I guess I have to find out. We have separated it, taking common, and then this is become the expression. I guess becomes 1 by ls plus r. This factor goes here, and this entire. Okay. Now for a steady state value, for that is t tending to infinity, in time domain. For this, in Laplace domain, it is called final value theorem. In Laplace domain, it is given by limit s tends to 0, s function of s. For to finding t tends to infinity value in time domain, you can take this s function of s, that limit s tending to 0. It is called final value theorem. So steady state value we are calculating from Laplace transform, that is s tending to 0, s tending to 0, sis. So s multiplied s into is. This is is. Here I am writing, just you can understand, for s tending to 0. Just put s is equal to 0. Just put s is equal to 0. When you put s is equal to 0, this factor, s will cancel, v naught by r. This will become 0, s cancel, v naught by r. There is no 1 by s term here, so this s will remain here, this will make it 0. Similarly, it will go to here, there is no s in denominator, so this s will remain in numerator, s tending to 0, s will become, s is 0, entire will become 0. If s is in multiplication, this is s is in multiplication, if tends to 0, entire part will become 0. S is in multiplication, if it tends to 0, entire part will become 0. This goes to 0, this goes to 0, only this factor s cancel, only this factor contribute, and this is v naught by r. Similar result we have obtained. So just these are the ways of understanding the things mathematically. Here also you can think in here also one other way to think it mathematically. Here at steady state it is L di upon dt. You can think like this also, just for thinking. We have already solved the question. IR, this is at a steady state. This expression tends to this expression at a steady state. Now, at a steady state, there is no change in current. Current becomes constant. Current becomes constant. That is V naught by R. Current becomes constant. Some constant. So this part becomes, there is no change in current. At a steady state, this is 0. I becomes V naught by R. You can look this. This is a way of seeing, observing the situation mathematically. Here also you can see, at a steady state, there is no change in current. No change in current. Voltage becomes constant. If the voltage becomes constant, the current is constant. The inductor at a steady state, inductor behaves as a short circuit, current becomes constant. No variation. Di upon dt 0. Again you are getting the simplicity. Whenever you think, look at the situation mathematically in a correct fashion, then also you will get the same result. Any way you do, either through this observation. Why I am going through multiple methods? Because a student should be very clear that how to see the things mathematically, that how to look the picture mathematically, and how we are getting same. They should be able to identify the mathematics behind the things. So you can see all these three results into same result. So you can see.